problem today. Um, so let's say I have a group of men and a group of women. And let's say each group is of the same size n. So I have n men and n women with me. First man, here's the second man, here's the nth man. Similarly, on this side, I have the first woman, second woman, and the nth woman. Now, what these men and women want us to do is they want us to match them with each other. So, what do we mean by matching? Well, it's exactly what you would think it means. So, basically, I would match maybe, for example, man one with woman one, or rather, woman two in this case, man two with woman one, man and with woman n. So, just make sure that some man gets matched to some woman and not leave anyone behind. We don't leave any man behind, we don't leave any woman behind. So, and how do we match them? So it's kind of boring if we just say, well, match them, right? So it becomes interesting when the men and women give us their preferences. And in this case, it's exactly what they have given us. So what each man and what each woman have given us is a list of preferences. So for example, man one tells us an ordered list of preferences among the women in which he wants us to match him. So, man one says that, well, my first preference is woman one. If she is not available for whatever reason, please match me to woman three. And if not, maybe woman four, and so on. But what's important is that the man gives us the preference order for all the women. So, this should be a list of n people, of n women. Similarly, we collect the same information from each woman. So maybe let's say the 10th woman, she gives us a list of her preferences among the men. So she maybe prefers woman man 6 to man 3. And if neither of them are available, maybe she says, okay, maybe please match me with man 1, and so on. But once again, it's important that she gives us the preferences among all 9 men, of all n men. Sorry. Now, this problem is entirely parameterized by this parameter n here. And when we get information about all the preferences of the men and all the preferences of the women, now we want to match them. Well, is there any criteria for matching? Yes. And the criteria, the so called fancy word for that criteria is stability. The men and women want us to create a stable matching among them. So, first of all, before we even proceed further, what do we mean by a matching? This is what a matching would look like. It's kind of a list of pairs where we have paired a man with a woman. Maybe man two, we have paired with woman three, and so on. And maybe the nth man, or here's the nth man. Maybe he is paired with maybe the kth woman, whatever value of k. So this is a matching, which maybe I can denote by a capital M. So it's M1. It's a matching. And as you can imagine, there can be different ways in which we pair a man with a woman and include all n men and n women. And we can come up with different matchings. So this is just one example of one matching. An interesting problem to consider here is how many matchings are possible. Let's see. Well, one way to think about a matching, and I will come to that as soon as I find my cursor. Here it is. So one interesting way to think about a matching is, let's say I fix the men on this side. On the left side, I fix n men. And what I do on the right side, I will look at all the ways in which I can arrange n women in order, right? So another fancy word for that is permutation. So let's see in how many ways can we make a permutation of n women on the right side. And let's look at any one permutation. So this is one specific way in which I could arrange women. So these are all n women, by the way, that I have arranged one in front of each of the n men. So I hope it's clear from here that each of these permutations actually results in one matching. So here, this is a matching in which woman 2 is matched with man 1, woman 3 is matched to man 2, and the sixth woman is matched to the nth man. So this is a matching. So the number of matchings are precisely the number of ways in which we can permutate these women on the right side. And that we know is the factorial of n. So, well, we now know how many matchings are possible. There are n factorial mappings, or matchings, sorry, when we have n women and n men. Now, here is where it gets interesting. It's kind of trivial to make a matching. What's interesting is when we see when these matchings are stable, because these guys, the men and the women, they want us to create a stable mapping. So here is what we mean by stability. Let's say we have created a matching and we are happy with it. This is our matching and we are happy with it. But somebody comes and analyzes and finds, let's say, a man, let me call him maybe the second man, M2. And we find that in our happy matching, we have matched man 2 with woman 6. Okay, so what's the deal? The deal is that if we go back and look at the preference order of man 2, we might see his preference order might have been woman 2, woman 3, so on, so on. Maybe woman 6 somewhere here, and maybe woman 7, and so on and so on. Right? That's okay. We didn't require everybody to be matched with their first matching, and in fact, that's not even theoretically possible always. So what we do see here is that man two is definitely not matched with his first choice, right? So there are a bunch of women who are above woman six in man two's preference list. But what we do see when we look at our matching, the matching that we have done here, what we do see is that if we go to, let's take maybe the second woman. Where is my cursor? Yeah. So if I go and look at woman 2, and we see that in our happy matching, woman 2 has been matched to maybe man 4. Okay, no harm. And if I go and look at the preference list of woman 2, and let's say I see man 1 was her first choice, and maybe man 2 was her second choice, man maybe 3 was her third choice, and man 4th, and so on and so on. She did get matched with man 4 in our happy matching. Well, no restriction or matching. We matched it. We matched everybody. But now we are going back and seeing how happy everybody is with their matching. And here is the criteria by which we define stability. We see man 2 has been matched with woman 6. He would have rather been matched to either woman 2, woman 3, or somebody else. And then we go and see the woman 2 who's already matched with woman man 4 in our preference list, but she would have rather been matched with man 2. So here is a cause of mutual instability. We have found a man and a woman, in this case, man 2 and woman 2. We have found a pair who would rather be matched with each other than their current matchings, right? So man 2 is matched with woman 6, whereas he would have rather be matched with woman 2. So we look at woman 2. Woman 2 would rather be matched with man 2, who comes above man 4 in her preference list, with whom we have actually matched this woman in the current matching. So these people, man two and woman two, would rather be happy if they be matched with each other. Now, okay, let's swap them. But then what about man four and woman six? What about these guys? Do we leave them hanging? No, we'll have to rematch them. But I hope this makes the kind of problem clear. This is the cause of instability. So every time we create a matching, one of these unfactorial matchings, we go and look for pairs of man and woman, a man and a woman, who would rather be matched to each other than anybody that they're currently matched with. And if we are to find even one such pair, we say that this matching, this kind of a matching, we say it is unstable and people are unhappy and we would rather not have any such pairs. This is an interesting problem, right? And it becomes interesting because if you think about it, if I give any kind of preference list for men and any kind of preference list for each of these N women, it's interesting to think, is it always possible to have a stable matching given these rules? So, is it always possible to match the men with the women in such a way that there is no man and woman who would rather be matched with each other than their current partner? Oh, by the way, just to make it clear, both of them, so it has to be a mutual instability. If I were to just find man 2 has been matched with woman 6, but would rather be matched with either woman 2 or woman 3. But if each of the woman 2 and woman 3, have man 2 lower in their preference list than the people that they are matched with currently, then that's not a case of mutual instability. The case of mutual instability arises when we have both a man and a woman who would rather be matched to each other than to their current partners. So here's the first interesting question: is it always possible to find a stable matching? Well, if it is, how do we find one? Interesting. The answer is yes, it's always possible. So a couple of people, Gale and Shipley, I think were their names, in 1962. They said, well, they declared it is always possible to find a matching which is stable given these rules, and they even gave us a strategy to find those matchings. So maybe let's look at how that's done a bit later.